Before I talk about dynamic memory allocation, I'm going to first talk about something that we're all used to, which is auto memory allocation. For example, let's say I have a scene, a class scene. It's going to have a constructor and a destructor. If you don't know what a constructor and a destructor is, check out video number 15. So I'm going to have a constructor for the scene, cout, scene is constructed. For the destructor, I'm going to say scene is destructed, and I'm going to create a scene inside our main function, make this public, and if I run this, here's our result. Automatically, for this function, scene is constructed and destructed. You don't really have to worry about memory allocation and deallocation yourself. This is the syntax that we've been using since the beginning until now, from video number 0 all the way to 17. Let me create a few more examples. I'm going to create a class called enemy. Again, I'm going to create a constructor and a destructor. Enemy is constructed. Enemy is destructed. Let me add an argument called index. I'm going to have a private int called index, 0 by default. And as the enemy is constructed, we cout the new index, as well as say that the index is what we designate. Also, as the enemy is destructed, we say which index it is. Let me create a function inside the scene called create enemy. So I'm going to do something like enemy 0, created with the index 0, enemy E1, created with the index 1, enemy E2, created with the index 2. Okay, inside our main, if I run this, scene, create enemy, F5. Okay, this is the same stuff from video number 15. The only difference now is that we specifically know which enemy is being created and destroyed. If I try debugging this, actually let me put a breakpoint here inside the function, run the debugger. I'm going to look at the address of E2. Okay, you can see the index 2. Let me show you something. E1 is right there. E0 is here. And you're going to notice that all of the enemies are literally stacked on top of each other, hence the name allocating on stack. So if you look at the address as well as the order, let me run this again just to show you. Okay, if we try to draw this, we see enemy 0 being created, and then we see enemy 1, and then we see enemy 2. This is like a literal physical stack, and the order that they get destructed is we go from the top, just like a physical stack, go from the top, E2 is gone, E1 is gone, and then E0 is gone. And you can see it in the result. This is also called contiguous memory. Don't confuse it with continuous. Continuous just means it's ongoing. Contiguous means that the memory is right next to each other or adjacent to each other. So automatic memory allocation is pretty straightforward. Inside this function, you know exactly how many ones and zeros you're going to need. And at the end of the function, you also know that those exact amount of ones and zeros can be freed. I'm going to try setting a breakpoint right here. Run this again. And for the watch window, I'm going to say address of E0, address of E1, address of E2. You'll see that we haven't even declared these enemies yet, but we have memory and address allocated for them. Again, this is called automatic memory allocation. Most of the object lifecycle is already taken care of for you. And again, if I press continue, everything is constructed and destructed automatically as long as you use this syntax, and these enemies exist only within the scope of this function. Now let's talk about dynamic memory allocation. One of the biggest differences is that you get to decide exactly when the memory gets allocated and deallocated. So inside this function, just as an example, I'm going to say do something. We're going to do a few things inside this function. Do another thing. And somewhere in the middle of the function, I'm going to use this syntax. I'm going to create a pointer for the enemy. I'll call it E3. And I'll create a new enemy. I'll give it the index of 3. Now, when you do this, enemy number 3, the memory for enemy number 3 doesn't get allocated in the beginning of the function, but it gets allocated right here. If I run the debugger again, we have the same breakpoint here in the beginning of the function. So we have the address for E0, E1, E2. E3's value is already an address. Check out video number 17 if you don't know what I'm talking about. So E3, we don't have an initialized value for E3. Until I press F10, until we create the enemy, now we have the address for E3. And just like what I talked about in video number 17, E3 is just a pointer that has an address to the object, enemy 3. E3 has its own memory address, and the value inside that memory address equals the address of enemy 3. If I press continue and see the result, we see the enemy number 3 being constructed. And again, if I try to draw this, we're going to have another memory block, only this time, instead of having the actual value of E0, E1, or E2, we're going to have the address of E3. And the value of this is going to equal another place in memory that has the actual E3. This is called dynamic memory allocation. It's very different from auto memory allocation. If I create another enemy, E4, I'm going to use the new syntax again. I'm going to set up a breakpoint here, run the debugger. I think I have to run this again. Okay, we have E1, E2, E3. I'm going to have E4. Let's also look at the memory. I'm going to look at E4. You're going to notice that this is contiguous memory. We have E0, E1, E2, the pointer to E3, and the pointer to E4. But if you look at the address of E3 and E4, they're quite far apart. They're not contiguous at all. This non-contiguous part of memory is called a heap, and you can see that for auto-allocated memory, we use the stack, and for dynamic allocated memory, we use the heap. Without going too deep into memory management, this is what the stack looks like, and this is what the heap looks like. For the stack, you know exactly how many ones and zeros you need for a function, so things are a lot more orderly. You construct objects in order, and you destruct them in reverse order. Fairly simple. For the heap, things are a lot less orderly. There is no predetermined order in which the objects are constructed or destructed. Instead, you have to explicitly say when you want to construct an object, when you want to destruct an object. I'm going to press continue and look at the result. And you might have noticed a problem here. When you're auto-allocating memory, you don't really have to worry about constructing or destructing. For dynamically allocated memory, we see that enemy is constructed, enemy 3 and 4, but you don't see them destructed. This is a serious issue because in this code, we never told the computer to destruct enemy 3 and 4. This is called a memory leak, and it's a serious problem for all apps. For this code, memory for E3 and E4 never gets freed. To solve this, you have to specifically say when you want to free the memory. And I'm going to use this syntax, delete E3, delete E4. And notice how I'm going from the bottom, E3 and then E4. It's a different order from destructing a stack memory. Let me add one more cout. just so that we have something before destruction of auto allocated memory. Yet do another. And if I run this, now we see that enemy number 3 and 4 are destructed. The difference here is that for enemy 0, 1, and 2, construction and destruction happens automatically. For 3 and 4, we have to tell the computer exactly when we want to destruct. The code itself is fairly simple. All we did today was have 2 different ways of allocating memory for the enemy class. If you auto-allocate, you don't really have to worry about destruction. For dynamically allocated memory, you always have to remember that at some point you have to free the memory that you dynamically allocated. And that's all it is. I've also seen people confusing the difference between the pointer and the object itself. For example, if I do something like this without the pointer, new enemy number 5, I can still do this. I'm going to press F5, run the code again. Obviously, you don't want to do something like this, but you can still create enemy number 5 without the pointer. I've seen a lot of people freak out whenever they see pointers, but in this case, it's just one of these variables. It has auto memory allocation, which you don't really have to worry about the destructor. Try debugging this yourself, and you'll see that the pointer is nothing more than an address. What you really need to be worried about is the object itself. There are many different ways to make sure that these objects get destructed. People have come up with things like smart pointers, different overrides, many different tools. I'm going to talk about those things later in this series, but for this video, let's just remember that when you dynamically allocate memory, at some point you have to deallocate them. I remember when I was starting out, I made the mistake of creating a new object on every single frame, and it went on until it crashed my entire computer. So again, remember that when you use the new operator, you got to delete it somewhere or deallocate it. And that's it for this video. For homework, try allocating memory dynamically yourself and try debugging and see what's going on in your memory. Let me know if you have any questions. You can reach me on my Discord server. I have all the links below. Thanks for watching. I'll see you next time.